Hi, everybody. So today we're going to be talking about 6.5, which is percents of increase and decrease. So before we start, make sure you have your math composition notebook out and ready. And you also have a writing utensil and that you are writing down everything that is on my screen as we go through. Okay, let's begin by writing the learning target. So our learning target for today is going to be, I will be able to use a percent of change formula to solve problems. So make sure you get that written down in your math composition notebook. Okay, so first we're going to talk about a percent of change. A percent of change is the percent that a quantity changes from the original amount, okay? And this is the formula for that. Okay, percent of change equals amount of change over the original amount, okay? And then what you would do is you would put this in your calculator. You would divide it in your calculator. So divide in calculator to then get the decimal, which then you would turn it into a percent. So what we did the first half of chapter 6. So pause it and make sure you get this formula written down. Okay, so the most important thing about this section is just going to be writing down the formulas and then making sure that you're plugging in the numbers into these formulas correctly. So let's talk about percents of increase and decrease. So when the original amount increases, the percent of change is called an increase, okay? And this is the formula for percent of increase. And I want you to write this down. It's going to be the new amount minus the original amount. I'm going to put OG amount over the OG amount, the original amount. Okay? So that is percent of increase. That is if the new amount is bigger than the original amount. So then percent of decrease, you probably can guess, that's just going to be the opposite. So percent of decrease is when it is decreasing. So the original amount is smaller than or is bigger than the new amount. So this formula is going to be the original amount minus the new amount all over the original amount. Okay. Okay, so those are the formulas for percent of increase and percent of decrease. Make sure you have those down because what we're going to do in the next couple examples is we're just going to apply these numbers directly into these formulas to get our percents of increase and decrease. Okay, so make sure you have these written down and then press play and we're going to continue on. Okay, so example 1, finding a percent of increase. It says the table shows the numbers of hours you spent online last weekend. What is the percent of change in your online time from Saturday to Sunday? Okay, so it gives you a table. So we are looking for what is the percent of change in your online time from Saturday to Sunday. Okay, from Saturday to Sunday. So Saturday is going to be where you start, so the OG, and Sunday is the new amount. Okay, so let's fill in our information. So it already tells us what is the percent of change, okay? So if you look from 2 to 4.5, is that increasing or decreasing? Is it getting bigger from Saturday to Sunday or smaller? It's increasing. So therefore, we are going to use the percent of increase formula. So write this down with me. Percent of increase equals, and remember, it is always new amount minus the original amount all over the original amount. Okay? So now we're just going to fill it in. So remember, the new amount is 4.5. So that's Sunday. So we're going to do 4.5 minus the original amount is Saturday, 2, over the original amount, which is 2. Okay, so then we're going to simplify that down. In my calculator, I'm going to go 4.5 minus 2 to get the numerator. And that's going to give me 2.5 over 2. And then in my calculator, finally, all I'm going to do is just type in 2.5 divided by 2. Okay, that is going to give me 1.25. So then remember, we then need to turn it from a decimal to a percent. So you can either multiply by 100 or move the decimal point to the right, to the right, and you would get 125%. Okay, so your answer would be your online time increased 125% from Saturday to Sunday. Okay, so the percent of increase is 125%. Okay, that's example 1. Let's look at example 2. Okay, so for example 2, we're finding a percent of decrease. So the bar graph shows a softball player's home run totals. What was the percent of change from 2012 to 2013? Okay, so 2012 to 2013. Well, 2012, it was at 28, and 2013, it was at 20. Okay, so it says the percent of change from 2012, so that's going to be the OG amount. That's going to be the new amount. So 2012 is the OG, and 2013 is the new amount, okay? Since it gives me 2012 to 2013. So if we look at this, it looks like between 2012 and 2013, the numbers decreased. The amount of home runs went down. It went from 28 to 20. So therefore, we are going to do percent of decrease. So let's write down this formula. Percent of decrease equals, well, the OG amount minus the new amount over the OG amount. Okay, so that is what we got. So the OG amount is 28, so we're just going to fill in our numbers. 28 minus the new amount is 20, so I'm going to fill in 20 over the OG amount. Remember, the OG is 28. Okay, now let's subtract. So 28 minus 20. Well, I know that's 8, but I'm just going to double check it in my calculator. 8 over 28. So then remember, you just divide in your calculator. You're going to go 8 divided by 28. And that's going to give me a long decimal. It doesn't tell me what to round to. So I am just going to round to the nearest tenth. So it goes 0.2857. So remember, you can either multiply it by 100 or you can move the decimal point 2 places to the right. So to the right, to the right. So that gives me 28.57. And then let's just round to the nearest tenth since it doesn't tell us what to round to. And that's going to give me 28.6%. So the percent that it is decreasing is by 28.6%. Okay? So that is percent of decrease. Similar to percent of increase, the formula is a little bit different. Okay, let's move down. We're going to talk about percent error. So I want you to write down this key idea. And percent error is the percent that an estimated quantity differs from the actual amount. Okay? And note over here, write this down in your notebook. It says the amount of error is always positive. Okay? You're not going to have a negative amount of error. It's going to be positive. So this is the formula. Percent error equals amount of error over actual amount. Okay, so let's take a peek at this example and we're going to apply this formula. So you estimate that the length of your classroom is 16 feet. The actual length is 21 feet. Find the percent error. Okay, so let's write down the formula. Percent error equals amount of error over the actual amount. Okay. Okay, so the amount of error, we're going to need to subtract first, okay? So what we're going to do is we're going to take 21 and subtract 16 by it. That's going to give us the amount of error. 21 minus 16 gives me 5. 5 is the amount of error, okay? That's because you estimated that it was going to be 16 and it was actually 21. So therefore, the amount of error is 5. So let's fill that into the numerator, 5, over the actual amount. What's the actual length? Well, the actual length was 21. So we're going to put it over 21. Then all you're going to do, take your handy dandy calculator and we're going to do 5 divided by 21. That's going to give you that decimal, okay? So it gives me a long decimal, so 0.238. Then we need to turn it into a percent. So you're going to move it to the right, to the right, to the right 2 times. And that's going to give me 23.8%. 23.8%. All right. And that is your percent error. You are off by 23.8%. Okay. That is section 6.5. Make sure you have this all down in your notebook, and we will begin the big ideas assignment soon. All right. Thank you for watching.